Now, before we get into the technical parts of encryption, it's probably helpful if we go over a few basic encryption terms and concepts. And these aren't very difficult to understand, but without a little bit of a background in cryptography, you may not understand them. So let's just take a few of them right now, and as we go through the course, we probably will go over a few other terms here and there that you probably will want to know, but we'll take it a little bit at a time. First of all, there's the term plain text. Now, plain text sounds like it just might be plain ordinary text, and to some extent that's true. But plain text basically could be a piece of text, but it could also be a message or any really kind of data, such as a file, that's in a human readable form or a form that any program could read without requiring a decryption. In other words, it's not scrambled. It could be a simple text document written out in Notepad that a human being could read, or it could be a Word document. Now, you might send this Word document across your email, and I could open it on my end when I receive it and open it easily without decrypting it. But someone who intercepts that email, who is sniffing the wire or intercepts that email, could go ahead and open that in Word also, so it's not secured. Those types of messages that are unsecured are said to be in plain text. Now, ciphertext is exactly the opposite. It's a message or a piece of data that has been encrypted. It's been scrambled, in other words, and is not easily readable. Okay? So now that we know the difference between ciphertext and plain text, let's talk about what encryption really is. Encryption basically is a process where you scramble a message or any other kind of information so that it cannot be read by anyone who does not have the right key. And we'll talk about what keys are in just a moment. But basically, encryption scrambles the data or the message. And as you might think, decryption undoes that process. To decrypt something means that we take an encrypted message, okay, and we unscramble it. We convert it from an encrypted form, which we called ciphertext, to an unencrypted form, which remember we said was plain text. That's all decryption is. It's the opposite of encryption. Now, before we go any further, let's talk a little bit more about the scientific terms. First of all, there's cryptology, and you may hear these terms, and it's helpful to know how they relate to each other. And some people use them interchangeably, and they're not really the same term. Cryptology is the science that covers both cryptography and cryptanalysis. So you might be thinking, well, what are those things? Well, cryptography is the science of hiding information. It's really the science of developing encryption methods and systems or technologies, or it's the science of encryption. Okay? Now, cryptanalysis is the exact opposite. It's the study of breaking encryption methods or systems, or breaking codes, or trying to break an encrypted message. It's trying to decrypt a message when you don't know the key or the algorithm. It's basically you have an encrypted message and you're trying different methods to break it. That's cryptanalysis. Now let's take a little bit further and get to some of the technical terms. We have two very important terms associated with encryption. That's algorithm and key. Okay, we've mentioned these a couple of times before peripherally, but let's define what they are. An algorithm is essentially nothing more than a mathematical formula or a mathematical method that's used to scramble the bits of a message. Basically the ones and zeros, the binary data of a piece of data. It scrambles it from its original form, which we called plain text, and it's unencrypted, into ciphertext, and it becomes encrypted data. Okay, this mathematical formula does that. Now, don't be alarmed if you don't understand the definition just yet. We're going to go into algorithms a little bit more in depth in the next session or two. Okay. Now, the other thing you need to know about encryption is a key. Now, an algorithm, when used with a key, basically makes encryption happen. Okay, a key is a secret piece of information. It could be a password, it could be a personal identification number, it could even be a digital certificate. Okay, and we use that in conjunction with an algorithm to encrypt data. In order to encrypt, we need two things: an algorithm and a key. In order to decrypt, we need two things: the same algorithm and maybe the same key, maybe a different key. And we'll talk about that in a moment as well. There are two kinds of encryption that we'll cover during this course. We classify encryption two different ways. First, there's symmetric encryption. We might call it symmetric key. Some other terms might be private key or shared key or session key. Whenever we see one of those terms, we're talking about the same thing. In this method of encryption, there's one key, and it's shared between the two parties that want to exchange encrypted messages. If I want to send you an encrypted message, I have to have a secret code, a key, or a secret password. and I encrypt that message with the key. And in order for you to decrypt it, you have to have that same key. That's why we call it symmetric or shared key encryption. And again, we're going to go a little bit more in depth on that as we go. Now, not necessarily the opposite, but the other kind of encryption that we'll talk about is asymmetric, and it's called public key encryption. Now, in this method, let's go back to the scenario. I want to send you an encrypted message. I can encrypt with a key, and in order for you to decrypt it, you can have the other key. There's two keys involved, usually called a public and a private key. And don't get confused by the terms yet. We'll go over that a little bit later. But what you need to know for now is symmetric key encryption uses one key that we have to share. We both have to know it. And asymmetric key encryption uses two keys. I have one and you have one. And we use those keys to encrypt and decrypt messages or data. Now, as I said, right now, we're just going over terms, so don't get caught up around the axle about these terms. Don't get worried about them yet. We'll make them clear as we go. But these are just a few terms, and we're going to cover other terms as we go.